question.
Can anybody tell me what minute ventilation is? This is like one of the most important things to know. No? Alright, we got a good audience today. So minute ventilation is going to be the amount of air we breathe in and out in a single minute. Right? Minute ventilation. How we get that is going to be the respiratory rate times our tidal volume. And to be 100% proper, it's going to be our ETV, which is our exhaled tidal volume. And we'll get into that. So some of the reasons why you want to know that. Somebody comes in here, they're breathing a lot. You see them taking full breaths. So we know it's going to be 500, 600, 700 mils. So we kind of want to match that until we find out what's going on. Maybe it is a DKA patient or something like that, right? So we don't want to just go to 12 and 400 or 12 and 500, which would be normal settings. We want to kind of match that, even though they're not on that. For transport or anything like that, I always get their minute ventilation and I match it because we're switching from a different vent anyways. Other ways you could do it if you have them on, if you put them on end tidal, match your end tidal is another way to do it, right? Let's keep things the same. If that patient's breathing a lot and they have an end tidal at 20 and it's not a perfusion issue, match that end tidal and play with your numbers until you get in there and we see what's going on with the patient. And a normal end tidal is 35 to 45. If anybody didn't know that, just remember what's your normal range for pH is 35 to 45, right? So when we talk about minute ventilation ranges, typically adults should get 100 mils per kilogram a minute. Pediatrics is 200 mils, and infants is 3. So start with adults, 1, 2, 3, 100 mils per kilogram per minute of ideal body weight. Teach you how to do the ideal body weight too. So the real equation for ideal body weight is going to be the height in inches. Did you get a?
I do actually have one. There's 2 of them that we're going to be putting onto the Hamiltons.
Minus 60 inches. And then you're going to plus 50 for males and 45.5 for females. And then you're going to times that by 2.3. Complicated, right? Why even do that, right? So why not go, if you're, how do I put this? So why minus your 60? We already know that, right? So 60 is what, 5 foot? So let's just times everything over that. So if there were 5'8", let's just times that by 2. And that would be 16, right? So we would have 76, right? Does that make sense?
Mm-hmm.
Let's kind of make it easy. Because everything we do with a ventilator is based off of ideal body weight. I could be 680 pounds right now. No, I'm 640, but it's okay. My lungs should be the same as someone my same height, right? That's where a lot of the trauma comes in, with the lung, the barrel trauma. We won't get into the shifts yet.
Can you repeat that again instead of minusing the 60?
Okay, so if you know somebody's 5 foot, that's 60 inches. So you just leave that, right? Then you take whatever's over that, so, and times it by 2 and add that to the 60.
So if they're 5'8", it would.
8
be
times
16
2 would be
plus
16.
16. So it'd be 7'6" for graduate.
Okay.
I'll save this part for a different day. Alright, the next thing we'll get into, does everyone have like vent experience? Okay, so this will be probably easy for you, probably not as easy for you. So, modes of ventilation, CMV. The traditional CMV mode means it's a controlled mandatory ventilation. So I'm going to set, say, a rate of 12 and a tidal volume of 500. So that's all they're getting. Nothing more, nothing less, unless something starts happening. Why I bring that up is because this mode on our vent is labeled CMV. So Hamilton didn't stick to that traditional verbiage, vocabulary. We'll come back to that. I just want to, why we're going over this. Assist control. So I set my rate and my tidal volume. So if I set 12 and 500, I will get that. If a patient breathes, so if there's a pressure change in the vent tubing, or if you wiggle it around too much and it senses any pressure change in that tube, it's going to think that patient's trying to breathe. And on that mode, assist control, whatever you have your volume at, it's going to try and push that whole volume in. So that's where it kind of gets confusing, where you see exhale tidal volumes over here, down here, up there, and then you're like, I'm not really getting these consistent numbers. So you would look at the vent and look at the frequency on how many times they're actually breathing. Because you might have them set at 12, and then you look at their frequency and it's 22. SIMV, that's the most common mode that everybody uses. So SIMV will actually sync breaths. But, so if I set 12 and 500, they're guaranteed to get that 12 and 500. If they take an extra breath, they're only going to get what they can pull on their own. You can add pressure support, and that will help them initiate and pull more. But that's all you're going to get on that breath. So you're not guaranteed any kind of volume on that. But the nice thing of this mode is, so say I'm coming on this waveform, I took a full breath, it was the one of the machine ones, they triggered it, they only took half of one, it's not going to start stacking all of those on top of each other. So it's going to automatically compute in there and say, hey, I need to give this much time for the patient to exhale, right? So it is a very nice mode. You'll hear someone say that they're paralyzed, they should be in assist control. What would you think the difference between someone paralyzed and assist control? Remember, that's 12 and 500. And if they take an extra breath, they're going to get the 500. What would be the difference between assist control and SIMV if they're paralyzed? Nothing, right? Because they're not going to take a breath if we have them adequately sedated and paralyzed. So those two modes are similar when they're paralyzed. I'm not going to go over waveforms, but you guys are going to know. So I will go over I to E ratios. Does anyone know what those are? So with this vent, I think it's set up that we're gonna change the I time, which is how long we take a breath in, right? So there's a button, I think it's 1 to 10, we'll go over that. But that doesn't mean that breath is going in under like 1 second. And then if you go down to like 0.09, it doesn't mean the breath's traveling in 0.9 seconds. What you really want to look at, you know, the lower I go, the faster that breath goes in, which is going to expand my exhalation time. And that's like later on when we get into the graphs, you could really tell like, hey, I got this person dialed in nice. I like it. I might take a picture of that screen and go home and show my wife. Like, look how good I did. Just remember, somebody's norm is going to be like that 1 to 2.2, or let's just keep it at 1 to 2 ratio. That would be your I. So 1 part inspiration, 2 parts expiration. So remember, when you get into your asthmatic stuff like that, they're going to need more time to what? Exhale. So I'm going to drive that breath in there a little bit quicker, allowing that I ratio to expand to maybe a 1 to 4. Right. And then positive end expiratory pressure. We all know what that is, right?
Beep.
Beep. Okay. You're going to learn something very interesting on this one about the beep. I think that's good for that section.